Well, good morning, everybody. It's lovely to see people already engaging in the chat and saying hello to each other, and I particularly enjoy people waxing eloquent. I see people talking about this exquisite Friday morning and how superb they are feeling and such, so that is absolutely lovely. So do say hi in the chat to each other, to me. It's very nice to talk to each other and to remind each other that even though we're not in the same room, we are in this class together, and hopefully we can build a little bit of kind of camaraderie and stuff. And definitely I hope the labs and things are helping with that. Speaking of not being in the same room, I am going to do the same thing that I did on previous days this week. So we had the Monday group, we had the Monday lecture, the Wednesday lecture, and now I'm also getting to the why don't I try that again? We have the Monday lecture, the Wednesday lecture, and today I am going to get the same information from folks about where you are watching this remote lecture. And that's just going to help us to understand, the needs that you have for the remote lecture, etc. And someone also is saying bonjour in the chat. I do have to say, sorry for scaring somebody yesterday. I was walking through the UC and I was on the way to get a coffee or something, and I saw somebody watching the 1020 lecture on their laptop and catching up on something or watching something again, and I walked by and I gave him a big thumbs up, and I don't think you recognize me because my mask and whatever else, and so somebody was like, who is this weird guy giving me a thumbs up in the UC? I don't know who this is. So anyway, if that was you, then I'm sorry if that kind of freaked you out or something. Okay, there are also some comments in the chat from Ms. Hogan talking about Gradescope being open for logbook entries and scripts from the lab, so do check that out as well. Okay, I'm going to give us just a few more seconds. Seems we're a little slow to get answers in this morning for that question about where you're watching the remote lecture, but hopefully that has popped up on your phone. Oh, someone in this chat said, that was me. So, hello. All right, hopefully I didn't freak you out too much. Okay, I'm going to have a look now and see where people are watching this lecture from. And okay, we've got... All right, a contingent in 2006, a couple upstairs in the engineering building. There's two of you, so maybe you can wave at each other. We have someone else elsewhere in the engineering building, but again, a good contingent in the library. Okay, and some other places as well. I'm actually kind of curious, and I wonder, for those who are in the library, maybe you could just say in the chat, if you're happy to, nobody has to, if you are like in a study room, and if that's something that you like book all day, or if that's something that you use just for 1020, or if you're one of the common areas in the library. There's no particular impetus other than A, curiosity. We like to encourage curiosity, and B, it may affect the way that we think about how people prefer to kind of watch the remote lectures and engage with the material, which may have some kind of effect on the kinds of rooms that get offered in the future for watching remote lectures. Okay, so the quiet area, the quiet area, the quiet area, common area. Okay, so people are mostly in the quiet room as opposed to in like a booked study room. Okay, that's interesting. Well, there are several of you there, so if you want to, maybe stick your hand up and wave, and maybe somebody from a higher level or down on a lower level will see you, and it's like you're all participating together. Okay. Someone says there are nice chairs at the top of the quiet room, so comfy chairs are definitely a good idea. All right, so let us get on to the topic du jour. We are going to talk about ranges and lists. So what do I mean by that? Well, remember last time we were talking about strings and how strings are sequences of characters. And we can do things like iterate over strings and look at each character inside of a string. And we can do things with those characters like convert them into their integer representation. So every character has a numeric code that is used to represent that character, and that's the thing that the computer actually stores internally. If you say, what is this wizard character? Well, I guess Gandalf and Sauron are wizard characters, but a character in terms of a glyph that is stored in a font, etc., there is a number that represents that character, or the letter A, or the letter U, or an exclamation mark, those kinds of things. So we talked about strings and characters and how we can iterate over strings and do things with individual characters. And we introduced those Python functions char and ord. So turn an ordinal number into a character, or turn a character into an ordinal number. Say, what is the number that corresponds to this character? Okay, before that, we were talking about iteration in a slightly more general way. We were talking about how iteration, excuse me, can be used to walk through a bunch of things, one thing at a time. We talked about design iterations in real life, and then we talked about in computing that this typically involves a loop. So a for loop is something that allows us to iterate over a value that contains multiple things, and at that time we said the only thing we've seen so far that we can iterate over is a string. But there will be more things. There will be things like lists and arrays and iterators. Well, the day has arrived. We're going to talk about a couple of more things that we can iterate over that will help us solve programming problems. So today we are going to talk about iterating over ranges of integers, which turns out to be a really, really useful thing for solving all kinds of problems. We are going to talk about lists, and we're briefly going to mention iterators. All right, before we get into those things, though, let me ask you a question in Top Hat. So here's the Top Hat question. What is the sum of the squares of the first 10 whole numbers? By which I mean 1 squared plus 2 squared plus 3 squared up to 10 squared. So remember, natural numbers are the integers from 0 and up. Whole numbers are the integers from 1 and up. All the integers include positive numbers, negative numbers, and 0. But right now I'm looking for the sum of the squares of the first 10 whole numbers. People taking a minute to do some computation, and that's good. We're here to learn about how we can make a computer do some computing. But first, we're going to do some computing ourselves so we can have some sympathy for the poor old computer when it has to do all that computing. All right, we've got answers coming in. I'll give you just a little bit more time. This is a question that involves adding up a few numbers. And look, I did it again. Sorry. One of these days, I will remember to put myself into picture-in-picture mode as soon as I start presenting slides and things. Okay, I'll give you an extra minute. Either that or like we need to have a well-produced television show with multiple camera angles and a technical director doing video switching. And well, maybe we're not going to get quite to that level of sophistication, which means you'll have to rely on my memory, which is a little bit less reliable sometimes than a computer's memory. All right, so we've got lots of answers coming in. I'm going to close this out now in just a few seconds, maybe in something like 5, 4, 3, 2, 1, and close it. Okay, so we had a few different responses. However, it looks like most of you had indeed the correct number. So how did you do that? How did you figure that out? You might say, well, I mean, it seems kind of obvious, isn't it? I calculated the sum of the squares of the first 10 whole numbers. But how do we break that down into smaller steps? Some people are quite clever, and they found the closed-form mathematical solution for the sum of squares. So, okay, that's very good. Let's say that we did this in an iterative way, because there are some problems that we can find a closed-form mathematical representation where there is a particular formula, a particular expression that will just give you the answer. There are lots of other problems where no such closed-form solution exists, and therefore what we need to do is calculate all of the different ways of solving a problem, or we actually just need to iterate through a bunch of data and run the computation. So anybody want to say how we found the answer to this? How do we find the sum of the squares of the first 10 whole numbers? Or even better, what is one small piece of the work that we had to do in order to solve this larger problem? So remember, some of the things that we do here, your big, complex, sophisticated, well-educated brain has been solving problems long enough that you might almost kind of forget what some of the small steps are that you're taking. You're so used to thinking about bigger picture ideas, more abstract ideas, that you might not even think anymore about how did I do that little detail. I just kind of gloss over that detail. But if we're going to learn to teach computers how to do things on our behalf, we need to understand those little details enough to teach the computer about those little details. All right, so I don't see a lot of engagement on the chat. Not a lot of people wanting to say what we did. Okay, that's fine. I'll give you an answer. So to find the sum of the squares of the first 10 whole numbers without a mathematical closed form, here's just a formula. One way we could do that is one small piece of that is for each of these numbers that we're interested in, we square it, and then we add it to something. So what that something is, well, I guess we're going to have some kind of a running total. And so we're going to look at the first number, square it, add it to the running total, look at the next number, square it, add it to the running total, etc., until we're done. So if we think of this in terms of a loop, then we would be able to look at the iterative step. The thing that we do every time we go through the loop is to take whatever the current number is, which means we need to have some understanding of a current number, and then we're going to square it, and then we are going to add that into some kind of a total. So as we've said before, whenever we're designing things, designing loops, we want to start from the inside and work our way out. So the thing we repeat in our loop is we take whatever the current value is and we square it, and we add that to a total, and that means that we have to have some kind of a total value until we're done. All right, so how can we convert these things into, well, actually, no, sorry, before we get there. So we've thought about what's the step we do every time. Now let's think about how we start and how we finish. So there is some kind of a current value, so we better start with the current value is 1, because I said we're going to do this for the first 10 whole numbers. And we might say that the total is, what should the total start as? Yeah, the total should start as 0. And thing we repeat in our loop. So for each value of current value from 1 to 10, we get the current value squared, and we add that to the total. Okay, so how can we convert some of these things into Python? So let's see, the current value is 1. Can you suggest a Python statement that we could replace this with? So this is perfectly valid pseudocode. So if I ask you, say on the midterm on Tuesday, to write some pseudocode for some kind of an algorithm that I ask you to design, and it'll be, fairly small because we only have 50 minutes for the midterm. So if I ask you to do that, pseudocode is very flexible in terms of, we don't have very specific picky rules over syntax. This would be great pseudocode. But how can we turn the pseudocode for the current value is 1 into, yeah, there we go. We've got some things in the chat. So maybe something like current value is equal to 1. Okay. Similarly, the total is 0. Well, we're going to initialize a Python variable called total using an assignment statement with the value 0. Okay. Now, let's look inside of this loop. How do we get the current value squared? I see typing. Oh no, the typing stopped. All right, so current value, and what is the exponentiation operator in Python? It is 2 asterisks. So current value squared, and we can, if we want to, we could save that in a variable. And then how do we add that to the total? Well, total is assigned by total plus squared. Okay. By the way, this assignment statement, total is assigned by total plus squared. This is something that we see so often where you have a variable is updated by whatever its current value is plus something or minus something or times something or divided by something. We see this so often that actually there's an even shorter syntax for saying this. We have, instead of a regular assignment statement, we can have a compound assignment statement. So instead of saying total is assigned by total plus squared, we could just say total plus equals squared. Or if we wanted to subtract something, then x minus equals y, x times equals y, x divide equal y, x integer divide equal y. So we have those compound statements that we can use. And that is a slightly more terse syntax, but it means the same thing. Okay, so squared is equal to current value to the power of 2, total plus equals squared, and then this part of the loop. So with the loop things that we've learned so far, the only kind of loop that we can work with right now to have a condition that will stop when the number gets to 10 or after our current value gets to 10 is a while loop. So what would the condition look like for a while loop here? Oh, someone says, I spelled squared differently. Ah, you're quite right. I missed a U. Thank you for that. Python would not be happy about that. So what would the condition be? As long as something is true, we want to do this over and over. Take the current value, square it, add that to the total. All right, so while the current value is less than or equal to 10, because it starts as 1, and we would like to add up the square of 1, square of 2, square of 3, all the way up to and including 10. Okay, so, and then maybe at the end, after we're done our loop, let's print the total is total. Okay, is this correct? Is this all good? I'm going to say it's not. There's something wrong here. Let us walk through this code. So I'm going to try to debug this. And so we'll step over here. So we're going to, and I will open our variables pane. So current value is 1. Total is 0. All right, so let's step into this loop. So while current value is less than or equal to 10, what is current value? Well, let's go look at our variables, and it is 1. So while current value is replaced by 1. So while 1 is less than or equal to 10, is 1 less than or equal to 10? Yes, it is. So we step into the loop. So we will square the current value, and we will add that to our total. And then we'll go around the loop again and check our condition. While current value is less than or equal to 10, all right, current value is equal to 1. So while 1 is less than or equal to 10, well, that's true. So we step in, we square the current value, we add it to the total. Uh-oh. As I keep going around and around and around and around and around, what do we observe is happening about our variables here? Right. Someone said in the chat, this will keep squaring and adding 1. And in fact, it'll keep doing that forever. So this is an infinite loop. I've made a mistake here. What's the mistake? So was the problem to add up an infinite number of squares of 1? No, the problem was to add up the square of 1 plus the square of 2 plus the square of 3. So every time we go around this loop, we also need to increment the current value. So with the kind of more verbose syntax that we've been using until now, current value is equal to current value plus 1. And what is the terser syntax that we could use for that? Yeah, someone said in the chat, current value plus equals 1. Now, we can actually make this a little more terse. It is a convention when we are working with, just like in a mathematical notation, you might have a big sigma notation where I goes from something to something, where I means the index. Well, it's kind of conventional when we have a loop that has a bunch of values that we are iterating over that go from like 1 up to 10 or 1 up to 1,000,000 or whatever. It's kind of conventional that we often call that I as well. You don't have to. And at this point, if we're saying squared is assigned by I to the power of 2, I squared, well, maybe we don't need to store that in a separate variable. So in fact, maybe we can make this code a little bit terser even. Now, we want our code to be understandable, legible, readable to other students and other people who are going to come along and read our code. Because remember, people will read your code, or people will spend more time reading your code than computers will. But this is such a common convention, and you already know it from mathematics that I is a pretty common variable name to use there. And now we'll see that when we run our program, it tells me that current value is not defined. That is true. If I'm going to change I in one place, I should change it everywhere. If you're using, by the way, one of the reasons that people use IDEs, integrated development environments, things like Visual Studio Code, is because unlike Thonny, they provide support for things like right-click on a variable and say, I want to rename this variable, and it will find everywhere that you use the variable and rename it for you. So those are the kinds of convenience features and part of the reason why people use IDEs. All right, so now if I run this script, it says the total is 385, which is the same answer that people gave previously. So that's great. Now, how about this? What is the sum of the squares of the first n whole numbers? Now, some very eager beaver, clever person is going to put in the chat something about a closed form mathematical solution. But if we wanted to change our program to compute the sum of squares of the first n whole numbers, how would we change it? I see typing is happening. Right, we could take some input from the user. That would be a good thing to do. So let us do that. So let's ask the user. What is the value of n? There we go. Is this going to work? No, we need to now, instead of saying while I is less than or equal to 10, we need to say I is less than or equal to n. And now there's one more problem. And what's that problem? There's something wrong here on line 1, this line that I just created. Or rather, I'd say something missing on line 1. Yeah, int. Good, because if we try to run this program, we will say, what is the value of n? And I want the sum of the first 100 whole numbers. And so we create I, we create total, then we check, is I less than or equal to n? Well, I is 1, n is the string 100, and we're going to try to compare those. No, that's an error. So we need to take that input and turn it to an integer. So now I'm going to run my program and the value of n, so I'm going to look for the squares from 1 to 100, and boom, we have the answer. Or if let's see, up to 10,000, boom, I have the answer. And look how fast it is, right? It's like that. Because computers are not smart, but they're fast. They can follow instructions quickly. Okay. But, so this works, but there are a couple of slightly annoying things here, right? When we were iterating over these integers, so we wrote something that looked approximately like this, or almost exactly, no, there I said I times I, but in the example we just wrote, I said I squared. But, it's approximately the same thing. But of course, we have this mathematical notation that is a bit terser and a little more elegant, because mathematics is always elegant, or it is often very elegant. But they kind of look the same, right? We have an I being initialized to 1, and I is going up to and including n. We have I squared. We have a summation of those things. If only we could make our Python code just look a little bit more like that mathematical representation. If only we didn't have to worry about some of these easily forgotten details, such as this I equals 1, or such as, oops, we forgot to increment I. I guess that's going to create an infinite loop. Wouldn't it be nice if we could write something a bit more like the mathematical expression? So you might say, well, boy, it's really too bad that we can't write, for each I within the set going from 1 up to n. Not sure why I wrote 2 there. From 1 up to n. It's too bad we can't write something like that, right? Right? Or can't we? You probably saw that coming. This here, square bracket 2 comma n close square bracket. What do we call that in math? That is a what of integers? Or a what of numbers? A range, yeah. So as x range, or as we look at each value of I in the range 2 to n, and the square brackets there indicate that those things are inclusive. And sorry, typo, off by 1 errors can be quite common in programming. So I should have written 1 comma n, I wrote 2 comma n. I'll try to fix that afterwards. But we could, or wouldn't it be convenient if we could write something a bit more like that? And well, you're probably not surprised to learn that we can. So Python has a function called range, and it is a built-in function, so you don't have to import math or anything like that. There is a function called range. It's actually slightly more complicated than just a function, but we're going to start with it being, at the very least, behaving like a function. And so what range gives us is a range. And in particular, it gives us a range of integers. And that range is something that we can iterate over just like a string. So if we want to iterate over the numbers from 1 to 100, we can write something like this. So the range function, if you give it a single argument, if you pass one argument into the range function, then it will iterate over the integer starting at 0 and going up to that number. So in this case, I said for each value that we're going to call n within that range 100, print n. What's that going to do? What is that little snippet of code going to print for us? You don't have to reproduce the entire thing that it's going to print. What's that snippet of code going to print? Come on, somebody wants to tell me in the chat. Being very quiet today. Right, it's going to print 1 and then 2 and then 3 and then 4 all the way up to 100. That's right. And each one will be on a separate line. Uh-oh, somebody's trying to type them all in now. Yeah, so we don't have to go all the way to 100. But yes, it's going to print all those values. If we wanted to use this in our little example that we were working on, instead of saying that we better initialize this variable I to 1 and then check while I is less than or equal to n, etc., instead we could, for I in range, and we have two different ways, well actually 3 different ways that we can use range. So I've said that if we pass range an argument, just a single argument, it'll give us all the values from 0 up to a particular value. If we, and so, yeah, in fact, let's even type that in, what we had in the slides there. For n in range 100, print n, and I'll press enter, and we'll see if it prints what we said. And it prints, almost exactly what we said. What is the one difference between what we observe here and what people said in the chat? Yeah, good. Someone said in the chat that the last integer is not included. So on our previous slide, we had our mathematical range that we showed here, we had these square brackets to indicate that this was inclusive of 2 and inclusive of n. Well, in using the Python range function, that gives us something that is inclusive of the beginning but exclusive of the end. So it iterates up to but not including the number that we wanted, which means, or the number that we specify, which means that if we want to use the range function here, we would actually want to specify n plus 1. And if we use this range, then look, we can get rid of the while condition. We can get rid of that I plus equals 1. We can get rid of that I equals 0. And suddenly we don't have to think so much about, well, how do we begin that and how do we update it every time we go through the loop, etc. This allows us to focus more on the problem and less on all of the details that we need in order to implement the code that solves the problem. So range is a higher level abstraction. And having a for loop that iterates over a range allows us to focus on the details that matter, which in this case, for this particular problem, those details are just adding up a bunch of squares. So range is something that can be iterated over like a string. So we can use range like this. And if I run this program now, and I say n is 10, you see we get 385 again. If I say what is the sum of the first 10,000 squares, or squares of the first 10,000 whole numbers, what about the first million? Look at that. It took like less than a second to calculate 1,000,000 squares. Computers are super fast at doing repetitive mathematical things. Not smart, but they're super quick at doing those things. Okay. So there was a question in the chat, why does I have to be less than or equal to n? Just because the way that I set the problem was tell me about the sum of the squares of the whole numbers from 1 up to and including 10. If I said from 1 up to but not including 10, which is very often how people use ranges, right? If they say, I want a salary breakdown of the people who make 0 to 50,000, 50,000 to 100,000, 100,000 to 150,000 within the university or something. If people have breakdowns like that, typically they don't mean that if somebody makes exactly $50,000, they're included in both, right? Or very, very often, even in plain speaking, when we talk about ranges, we kind of mean that one end is inclusive and the other end is exclusive. So it's the same kind of thing. So we can use a range to provide a bunch of numbers that we can iterate over. And so we can use range by just telling it where to stop. We can also use a variation of the range function where we tell it where to start and where to stop. So we can say that we want values in the range from 10 to 20, or from 1 million to 1.5 million, or whatever starting integer and whatever stopping integer we want. And there's a third way that we can use the range function, which is to provide a start, a stop, and a skip. So we can say I'm going to kind of like skip counting. So like my 6-year-old is doing skip counting by 5, skip counting by 2s, whatever. So being able to skip count in a range of numbers, starting at, in this case, 1,000, going to 2,000, and skipping by 500. So in fact, yeah, that third bit here for n in range 1,000 to 2,000 by 500s, what will that print out? And this is something where actually we can type out the entire thing that it'll print, because it's not going to print 1,000 values or 2,000 values. Right, so someone asked, in this second case here, the 20 would not be included. That's right. So we start with a particular value and we stop just as we reach, or just before we reach that value. So inclusive of the beginning, exclusive of the end. As somebody put in the chat, it's like a square bracket, start, comma, stop, round, parentheses. Yeah, okay, so we've got a view about what that is going to print out. So let's see, for n in range 1,000, 2,000, 500, print n. And the answer is indeed. It prints 1,000 because we start at 1,000. Then we skip by 500. We get to 1,500. Then if we skip by 500 again, well, now we would be at the stopping point. So we're done. So we don't print out 2,000. Good. Okay. Where can we get more information about this really interesting and useful range function? Well, we're not just home on the range, there is help on the range. So Python also includes a built-in function called help. So when you need help, you can say help, and Python will tell you some useful things. So if we type, and I'll show you here in Thonny, if I say help, give me help about the range function, it will tell me, well, it'll tell me a whole bunch of stuff. Some of these details down here, we're going to ignore at least for now because they're not things that are terribly relevant to at least what we're doing yet. But some of this stuff at the beginning is quite helpful, as it should be because it's from help. So the help for range tells us there are two different ways that we can use it. One way involves giving it a place to stop. The other says give it a place to start, a place to stop, and then optionally a step. And so this gives us a sequence of integers from the start, inclusive, to the stop, exclusive by step. So we have some explanation of exactly what this function does, and this help function is something that's useful for all kinds of stuff, right? So, give me help about bool. Right, so what does bool do? And again, there's some stuff here at the bottom that's not particularly meaningful to us, but bool will return true when we pass it an argument which it can be converted to true or is true. Otherwise, it returns false. Let's see, from math import star. How about the help for degrees? If we want to know what degrees does, well, degrees is a function, and it converts an angle from radians to degrees. And so this help is extremely helpful, as one might hope it would be. So there are some details, and help will sometimes tell us a bunch of stuff that we understand some of it and we don't understand all of it yet because we haven't talked about classes and objects and methods and that's okay. But at the top, you'll see there's usually a short description of what does this thing do, or what is it for, or is it good to eat? Well, it won't actually tell you if it's good to eat. And that is the part that we can understand now that is really useful. So the big picture thing that we've learned about range here is that there's a couple of different versions of range, and well, depending on how you define it, it's either 2 or 3, but there are different versions of range, and we'll go into more details later. But right now, we see that range is this function that produces something iterable that allows us to iterate over a bunch of integers in a sequence, possibly with a skip. And so if we look at something like Project Euler, problem 1 is to find the sum of all the multiples of 3 or 5 below 1,000. You can see how, if you've already solved this problem using just a while loop, fantastic. But now I would take that solution and say, okay, how can I simplify that with range? So you saw that when I changed this implementation of finding the sum of squares, and I converted it from a while loop that involves setting up a variable called I or something like it, having a condition, and then remembering to increment I every time we go through the loop. Well, it was greatly simplified. I could get rid of this and get rid of this when I switched to using range. So do the same with that Project Euler problem. And if you haven't solved the Project Euler problem yet, then, well, go ahead and do it. And do it with the range function to start with. And that will allow you to focus a little bit more on, okay, for each of these numbers, what's the step that I actually need to take? What is the thing that I need to do with each number below 1,000 in order to find the sum of all the multiples of 3 or 5 below 1,000? I'll give you a little bit of a hint. And if you don't want to have a hint, if you don't want to hear a hint, then you can go la 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 la. Well, except for the people in the quiet room, don't do that. You can do that, I guess. But the hint is the modulus operator will be really helpful. So think about why. Okay. Any questions about that stuff so far? Nope. All right, that's fine. So what about other kinds of collections of values? So range is great if we want numbers like 1, 2, 3, 4, 5, or 0, 1, 2, 3, 4, or if we want 10, 20, 30, 40, or if we want something like that. The range is fantastic for sequences of integers where they are all either increasing by one or increasing by a fixed step. And that is the case for lots of problems that we might want to solve. But there are also, a lot of different collections of values in this world that are not just increasing in a sequence. So if I said, what is the student ID of everyone in our class? Well, I think very strongly it is unlikely that you are all going to have the student IDs 2021 00001, 00002, 00003. There might be a few people in the class who have student IDs that are pretty close to each other, maybe even right next to each other, but they're unlikely to just be a sequence in that way. We're going to have all kinds of student numbers from different years and with different serial numbers. If I had the grade for everyone in the class, your grades are not going to be, at the end of this course, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to 100. We're not going to have a perfect sequence that goes from 0 to 100. I certainly hope not, because then half the class would fail, and that is not a usual outcome. So we definitely don't want that. But we're going to have a bunch of people with different grades, and some of you are going to have the same grades. A lot of you are going to have the same grades. I mean, hopefully towards the higher end of the spectrum, I hope I have more than one 80 or 85 or 93. We'll see. That's going to depend a lot on you, but I'm kind of hoping that we will be able to have lots of people with lots of repetition of the higher marks and not a lot of repetition of the lower marks. What if I wanted to take the temperature every day? So we've said that a temperature, you might represent it with a float. So a student ID could be an int, a grade could be an int, every day's temperature, that might be a float, especially if we're doing this for precise weather monitoring or something. And those temperatures are not just going to be a sequence that starts at a particular number and then increments by the same amount every day. Now, the last 3 days, it might feel that way. It was cold and then less cold and now it's a bit warmer, but we don't actually want that to keep going up by the same amount every day because it won't be long before it's 10,000 degrees outside, and that's a little too hot for me. Or also other kinds of values, like for each day that we've had this semester, have we canceled lecture? Now, we have been very, very fortunate this year that we haven't had 2 weeks of lecture cancellations due to snowstorms and things. That often happens in the winter, so we're very fortunate in that respect. But we might want to store a bunch of Boolean values. Yes or no, true or false. Lecture has not been canceled. False, 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 false. True on this day, false, false, false. True on another day. So we might want to store a bunch of values inside one collection of values. And one way we can do this is with a data structure called a list. So we can have a list of student IDs, a list of grades, a list of temperatures, a list of lecture cancellations. And the syntax for a list is pretty straightforward, as we can see. There is an opening. What is that character called? That square piece of rectangular piece of punctuation. What is that character called? Yeah, nobody's typing in the chat. Nobody wants to say, okay, that's fine. So that is called a bracket. So we, just as programming languages can get a bit picky and get a bit precise about things like syntax, we're going to have to be slightly picky too. So a square bracket, So the square one is called a bracket, the curly one is called a brace, and the round one is called a parenthesis. So this is an opening square bracket. Then we have 0 or more expressions in our list, and those expressions are separated by commas. So if we have 2, then you'll see, for example, in the student IDs, here's a student ID, a comma to indicate that we're done with that one, and then another student ID afterwards. And you can actually have a comma at the end too if you want. So we're going to have an opening bracket. We have 0 more expressions that are separated by commas, and then a closing bracket. And that's it for the syntax of a list. So if I want to have a list of grades that let's hope people are going to have in this course, let's say grades are going to be 99 and 84 and 92, and maybe there's a 79, and then there is a 98, and so yeah, these are nice grades. And now I'm going to close that bracket. This last comma, you can have it, you can not, it's fine either way. But when I press enter, I assign that list, which contains these values, 98, 84, etc. Actually, you know what? We've got a bunch of clutter here because I imported math, so let's just do that again. There we go. So you see I have a variable called grades, and this one variable is a list with a bunch of values inside of it. So grades is one variable that contains one value, and that value is of type list. But that list has a bunch of values inside of it. So if I say, what is the type of the value in grades, I'm going to get the answer list. It doesn't say int because it's not an integer, it's a list. That list contains integers. And lists are things that we can also iterate over. So we can iterate over lists just like we would ranges. So instead of saying for I in range going up to 100, I can say for each grade in this list of grades. And I can even simplify that a little bit further if I wanted to. I could say for grade in 99, 84, 92, 79, 98, print your grade is grade. There we go. So for each of those grades, I've just printed out your name is followed by the grade. And so we can iterate over those things, whether they're grades or whether they're temperatures or whether they are Boolean values, or in fact, they could even be strings. So I could have a list which is all of my names. And well, why don't we do that? So my names are Jonathan, Robert, Anderson. Nobody ever calls me by my full name, except I guess when I was younger, my mother would use it. Jonathan Robert Anderson. And so you can see when I print, or when I look at the value of names, if I try to print names, it tells me that it is a list. And look at that syntax. It shows us the same syntax. Opening square bracket, expression, comma, expression, comma, expression, closing bracket. And so this common syntax is not a coincidence. The fact that we can iterate over characters in a string, we can iterate over integers in a range, we can iterate over values inside of a list using exactly the same syntax with the for loop is not a coincidence. So all of these things are using something called iterators. Now we'll see more kinds of iterators later. Right now we don't need to worry too much about the details of what iterators are or how they're implemented or anything, but we should know that in Python there are lots of different data structures that can be iterated over using iterators. And in fact, you can even make your own data structure and say that, well, I'm going to have something that represents a course, and I'm going to allow you to iterate over all the students in the course, or all the lectures in the course, or all the labs in the course, or you can decide what you want to be able to iterate over. But the kind of elegant thing that we have is that any value of any type that has an iterator that allows iteration, you can plug it into a for loop. You can put it into this place in a for loop and iterate over all the values inside of that iterable thing. And so the code for iterating over a string or a range or a list or other data types that we're going to see later is all going to look remarkably similar. It is, let me look at each individual element within this iterable thing, whether that iterable thing is a string or a range or a list or other stuff. Okay, so that is how we can iterate over integer ranges, and that is what lists are and how we can create lists. Now, as we continue in the course, and I think next week we'll look at some things like ways that we can do more interesting operations with lists rather than just create a list and then iterate over everything in it. Sometimes we're only interested in certain values inside of the list, and we'll talk about how we do that. But right now, we've seen how to create lists and how to iterate over lists using the for loop, which is based on iterators. And this should give you all that you need in order to play with even more problems in Project Euler. And I really do recommend, it's not the only source of interesting problems in the world, but it is a pretty good one. And if you can solve some of the first few problems, and there may be problems where you say, I don't know if I can do that one, but definitely in the first few, there should be problems that you can pick out and solve. And if you can do that, then that should give you some confidence that you're kind of moving in the right direction and that you understand the kinds of things that I'll ask you to understand on the first midterm, which is Tuesday. Don't forget that it's Tuesday. And in that midterm, I'll probably ask you to solve a simple problem. Maybe not as complicated as an assignment or anything like that, definitely, because assignments, you're allowed to go home and think about it for an hour or two and then try a design out and then it doesn't work and try something else. So I'm not going to give you problems that are that complicated in the middle of a midterm, but there will be problems that require the same kind of thinking. So I'd suggest Project Euler would be a great place to do some practice, because remember, just like a music degree, if you really want to be able to internalize this stuff, you don't just sit in a classroom and hear the theory, you go sit in the practice room and you work it out in practice. You take that theory that you've learned and you spend it on practice until the stuff becomes almost like second nature. And that is true in almost every field, but it's absolutely, definitely true in programming. Okay, any questions that people have before we call it a day? All right, I'm not seeing any questions coming up, so I guess that will be it for today. So I hope you all have a lovely rest of your day. And if you do have any questions or issues or whatever, don't hesitate to reach out. I know at least yesterday there was one student who was in the Success Center who was asking a question, and unfortunately I only had like 30 seconds that day. But today I'm quite a bit more flexible. So if you do have questions, please don't hesitate to reach out. So I hope you all have a great rest of your day. Bye.